Hello and welcome back to the course. In this section, we are going to study about the MD5 and SHA1. Okay, now as earlier we have seen about the hash algorithm and hash function that performs some kind of when we apply the hash function for the plain text or the message, then it is going to provide a single fixed size length of the ciphertext, and because of which we can say that that is the complexity level of the hash algorithm at both sides secures the message. Okay, now this next algorithm type that we are going to deal with is MD5. MD5 algorithm can be used as a digital signature mechanism. In this presentation, we will explore the technical aspects of the MD5 in the next coming slides. Uh, it takes an input as a message of arbitrary length and produces the output of the 128-bit fingerprint of the message digest of the input. A conjecture that it is a computationally infeasible to produce two messages having the same message digest. So it is intended that where a large file must be compressed in a secure manner before being encrypted with a private key under a public key in a crypto system such as a PGP. Okay, now MD5 is suppose a B bit message as input, and that we need to find its message digest. So steps which has to be followed are: step 1, append the padded bits, that is a message is padded so that its length is congruent to 448 modulo 512, means extend it to just 64 bits shy by of being of 512 bits long. Next is a single 1 bit is appended to the message, and then 0 bits are appended so that the length in the bits equal to 448 modulo 512. Step 2, in step 2 we are going to append the length. A 64-bit presentation of the B is appended to the result of the previous step. The resulting message has a length that it is an exact multiple of the 512 bits. Step 3 involves the initialization of the MD buffer. A 4-word buffer, that is ABCD, is used to compute the message digest. Here, each of ABCD is 32-bit register. So these registers are initialized to the following values in the hexadecimal form. Word A, 01, 23, 45, 67. Word B, 89, A, B, C, D, E, F. C, F, E, D, E, D, C, B, A, 98, and D, 76, 54, 32, 10. The process message in 16 word blocks. Now, in this particular case, for auxiliary functions, that takes as input 3 32-bit word and produces as output 1 32-bit word. So here it is written with the FGHI with the specific XORing conditions and some NOT conditions. So these are the equations which are being given. Then if the bits of the XYZ are independent and unbiased, each bit of FGHI will be independent and unbiased. So MD5 algorithm is a simple to implement and provide the fingerprint and message digest of the message of arbitrary length. So the difficulty of the upcoming of two messages with the same message digest is on the order of 2 raised to 64 operations. Next topic that we are going to have is a secure hash algorithm. Earlier, before, we have seen the hash functions and their properties and how it works. So now this in terms of the producing the security to the hash algorithm, how it is going to work out, then we are going to see the versions of that. So most widely used hash function is there, SHA. developed by the National Institute of Standards and Technology. It is published as a Federal Information Processing Standard FIPS 180 in 1993. When the weakness were discovered in SHA, now known as SHA-0, a revised version was issued as FIPS 180-1 in 1995 and referred to as a SHA-1. Here is the comparison parameters of SHA, in which we can say SHA1, SHA224, 256, 384 and 512. These versions are available, in which the parameters that we have chosen is message digest size, block size, word size and number of steps. So these are the version wise the message digest size, these parameters varies, in which we can say the SHA1, which is considered as the base of the rest of the versions, which is having the message digest size is 160, message size is less than 2 raised to 64, block size is 512, word size is 32 and the number of steps are 80. So SHA is based on the hash function MD4 and its design closely models the MD4. SHA1 produces the hash value of 160 bits. In 2002, the NIST produces a revised version of the standard FIPS 182 that identifies the three new versions of SHA. So SHA 256, SHA 384, and SHA 512 respectively. Collectively, these hash algorithms are known as a SH2. This is all about the SHA and MD5.